All right, hello and welcome to the notes for Unit 5, Projectile Motion. All right, we're going to kind of breeze through this. You can pause the video at any moment that you need. But projectile motion, the definition of a projectile motion is an object traveling through the air with only the influence of gravity acting on it, right? Like this awesome... a snowmobile, as he jumps through the air. He's a projectile because only gravity is pulling down on him. Right? There's no other forces as he's in the air. That is a projectile. Okay, trajectory. The definition of this is the parabolic path that a projectile follows. It's literally just the path that it follows. It's It's a parabolic. Okay, the first two Newton's laws play a huge role in projectile motion because as a projectile flies through the air, horizontally there are no forces on it. And according to Newton's first law, an object that has no forces on it will travel at that same speed forever. So if there's no horizontal forces on a projectile, there will be no acceleration, meaning it will stay at a constant speed. But vertically, because there is a force, Newton's second law says that the acceleration of the object will be directly proportional to that force, resulting in an acceleration of 9.81. So, vertically, the object accelerates at 9.81 meters per second squared. Horizontally, it accelerates at 0 meters per second squared. The forces on a projectile motion, only one of them, and it's downward. And it's the force of gravity. And that's it, nothing else. Okay, elements of projectile motion. Here are all of the things that you can find out, you can study of a projectile motion. All right, now as we watch this video here, it's going to show the different elements of the velocity, of the component of the projectile's velocity. So here we go. Cannonball is shot. Okay, that orange velocity vector right there, that's the actual velocity. We call it the launch velocity. It's actually how fast it's going. But what we do as physicists is we make up these imaginary components. The red component is the horizontal velocity. The green component is the initial vertical velocity. Now, horizontally, we know this red vector is not going to change ever. The green one is going to shrink by 9.81 meters per second every second. Let's watch that. All right, at the peak, you can see the green velocity vector is gone because gravity has completely taken it away. It once was a positive vertical velocity, but now it's 0. And notice the horizontal and the horizontal and the actual velocity are now the same. But after the peak happens, the vertical velocity now becomes negative and goes downward. And right before it hits the ground, everything is back to the same as it was when it was launched, except it's backwards. The horizontal never changed, but the vertical is now downward. Okay, 7 facts of projectile motion. Number 1, there's only one force on a projectile, it's gravity. That's it. 2, the horizontal motion of a projectile is uniform, meaning it's constant. Meaning you only use one equation for it, V equals delta D over delta T. Number 3, the vertical motion of a projectile is non-uniform, meaning it accelerates at 9.81 meters per second squared, meaning you use the 4 equations of accelerated motion to find out anything you want about the vertical motion of a projectile. Number 4, vertical velocity is 0 at the peak. Number 5, the peak time is exactly half of the total time. Number 6, the launch velocity is the same as the landing velocity. Number 7, a half projectile is the same as half of a full projectile. So a half projectile is an example of that would be a car driving off a cliff. All right, and there you have it. That is the Unit 5 projectile motion notes.